so hello to everyone and welcome to our webinar, Private and Secure LLMs for AI Humans. This is being presented by DeepBrain AI with our special guest, Lenovo. This webinar will be recorded and anyone who registered will receive a link to the recording. We have about 30 minutes of content planned and we've reserved 15 minutes at the end for Q&A. So please feel free to enter your questions in the Q&A chat window, and we'll address those questions at the end. And without further ado, I will get started. So let's kick off with some introductions. And go ahead, Chris, why don't you introduce yourself?
Okay, thanks, Joe. Hi, everybody. My name is Chris Van Buren. I'm a data scientist at Lenovo, where I work on enterprise generative AI applications. So I'm going to share our document Q&A chatbot that runs entirely on-prem for private LLM usage.
Thanks, Chris. And my name is Joe Murphy. I'm a business development manager with DeepBrain AI. I've been working with DeepBrain AI for about a year and a half now since they've opened the US office. We're located in Palo Alto. And I've been working in the Silicon Valley Bay Area for almost 10 years now, working on a variety of companies, typically focused on AI startups. And the next person I'm going to introduce is actually a virtual human. Her name is AI Paris. It's just a demonstration of one of the models that we have developed here at DeepBrain AI. Paris is one of our most popular and widely used AI humans. There's a lot of demos that use Paris, and she's very expressive and friendly. So here's a video of Paris.
Hi there. My name is Paris, and I am a virtual human developed by DeepBrain AI. Virtual humans like me are deployed to create engaging customer experiences, learning and development videos, and much more.
So that's an example of just one. We have over 100 AI avatars that are our stock models ready to go. We also have many private or enterprise level avatars that have been developed for very specific customers. So let's talk a little bit about the AI human overview. At DeepBrain AI, what we do is we start with a real person on the left, and you could think about a real person and some of the things that make them unique, such as their facial expressions, how they move their mouth when they talk, how their eyes blink, their voice, their mannerisms, how they talk with their hands. All of this is captured in a video session that we do. It's about a 4-hour training session. And after we capture that data, we use it to build an AI human. The AI human is the avatar of that real person. And now that the avatar is built, you can think of the scalability of script to video. We can use this to create informational videos or conversational videos. And this session today is focused on our AI humans, which are conversational videos. So videos you can actually interact with. There's quite a few companies out there that work on AI avatars. So I want to take a moment to point out what differentiates DeepBrain AI from the rest. And the first thing I'll talk about is hyper-realistic nature of the avatars. We shoot the avatars in 4K, and our goal is to create an avatar that is nearly indistinguishable from the real person. So if you're looking at AI avatar developed by DeepBrain and video of the actual person side by side, our goal is that you can't tell which is which. And we do measurements to back that up, such as the structural similarity index measurement. And in this test, we are comparing the AI video to the real human-generated video, and we scored 96.5% similarity. And of course, you can imagine 100% means it is 100% similar. So 96.5 for our viewing purposes and for our clients is as good as the real thing. And here's an example of our avatar, Max.
Hello, I am Max, a hyper-realistic avatar.
So that hyper-realistic nature creates these realistic humans that you can interact with. But now we also need to think about gestures and how they move. So DeepBrain AI spent a lot of time developing frame interpolation technology, that allows us to have very natural gestures. So the avatars can point at objects on the screen and it doesn't look animated. It looks like the natural way a human would move. This is done through frame interpolation and gesture keyframing. These are technologies that we've developed in-house that enable us to do this. And the third thing that I want to point out about our AI avatars is real time, or how fast they are. Because if you're supporting a conversation, you need to be able to synthesize video in near real time. So when a person asks a question, you need low latency, so the video synthesis can start as soon as possible, and that answer starts flowing, so there's no unintended delays. We do this through streaming inference, distributed GPU architecture, and an extremely lightweight machine learning model that we've developed in-house. This is a look at our architecture at DeepBrain AI. You can see the guest or the user on the left talking to an AI human that is in a kiosk. And this could be a kiosk or a mobile phone or a tablet or a web browser, whatever the endpoint the client desires. The first thing we do is, as the user asks a question, we take that audio and run it through a speech-to-text engine. We can work with all the popular speech-to-text engines, such as Microsoft Azure, AWS, Google, even third parties. We work with many different ones. It's a simple integration for us to get that speech-to-text engine up and running. After the speech has been converted to text, it goes through an NLP chatbot. And again, same concept here. We can work with many different chatbots. We can work with intent-based chatbots, and most of the customer implementations that we've done to date have been based on intent-based chatbots. Moving forward, and what you'll see demonstrated by Lenovo today, is integrating with a large language model. So for the NLP part, either an intent-based chatbot or a large language model is suitable for integration. And that passes the answer to the DeepBrain software, where we do the video synthesis. So at the highest level, the user asks the question is fed as text to the NLP chatbot. The chatbot, which can be intent or language model, large language model based, passes the text to the DeepBrain SDK, and then we synthesize that answer and deliver the answer. I'll note here that all of this technology can be either on-premise or in the cloud. So the DeepBrain, the STT, and the NLP, any one of those components can be located in the cloud or on-premise. I'll share a couple examples. These are examples of some banking financial assistance that we've done in Korea. KB Bank was one of our earliest customers, and I'll play just a quick 30-second video here showing a customer interacting with a kiosk at the KB Bank Innovation Center.
만나서 반갑습니다. 무엇을 도와드릴까요?
예금 상품 안내해줘.
목돈을 거치할 수 있는 정기예금 상품 중 판매량이 가장 많은 5가지 상품을 추천해드리겠습니다. 상세 내용을 확인하시려면 상품의 이름을 눌러주세요.
So that's an example in the Innovation Center. Since then, the actual kiosk has been deployed in multiple KB Bank branches. You can think of this as a virtual lobby leader, someone who greets you when you enter the bank. They can ask you, how can I help you today? They can assist you with getting tasks done. They can guide you to who you need to talk to in the bank. They can even try to offload you to the mobile app and show you how to do those things on the mobile app. Very similar use case here is Shinhan Bank, and just another quick example of how natural and realistic the avatars are.
안녕하세요. 신한은행 서소문 지점입니다. 무엇을 도와드릴까요?
적금 가입하려고 왔어요.
올해 6월에 가장 많은 사랑을 받은 적금 상품을 안내해 드릴게요. 아래 상품 리스트를 확인해 주세요.
So in these kiosk formats, it's worth noting that these are multimodal. So you can talk or touch. So there's a complete user interface overlaid on top of the speech interface for very natural interactions. And right now, DeepBrain is already working with all top 5 banks in Korea. And next, I'm going to talk about our AI Human demo portal. And what we have is a portal where you can log in and try this out. So if there's anybody in the audience today that is thinking about implementing an AI human, and we kind of have this sandbox ready where you can go log in, create a project, select the AI human that you want to work with. You can see we have multiple available. And then after you select the AI human you want to work with, you can select the chatbot you want to work with. You can connect to ChatGPT. We can fine-tune ChatGPT, and it's a very simple process. Basically, you just need to upload the documents. We can also work with many third-party intent-based chatbots, such as IBM Watson, InWorld, Google Dialogflow. We have Webhook solutions. It's not intimidating, or it shouldn't be. If anybody wants to get started in the AI human demo platform, reach out to me after this, and we can set up an account for you, and you'll be up and running within a few minutes. And with that, I'm going to stop sharing and hand it over to Chris, who's going to show us how Lenovo implemented their very own AI human.
All right. Thanks. Hi, everybody. So I'm going to take you through how to implement a Q&A chatbot. And so this is great for if you have, say, an internal knowledge base, could be thousands of documents, and you might have people, employees at your company who would want to query that knowledge base, find some sort of information that's within there. But if it's within thousands of documents, instead of searching through all those documents, going through folders and reading the original documents, you can actually chat with it like it's a chatbot and easily find the answers very quickly. Not only that, we can do this all on Llama 2, which is an open source large language model from Meta. And I'm going to show you how you can do that with Lenovo hardware as well. So before we get started, I'll just show an example of how we've used DeepBrain as our interface for this chatbot. So DeepBrain is part of the Lenovo AI Innovators program. They're a partner of Lenovo's, and so I'm going to show an example case where we might ask about that.
Hello. I am Gabriella, a helpful and knowledgeable virtual chatbot representing Lenovo. The Lenovo AI Innovators program is a one-stop shop for enterprise AI, offering a diverse ecosystem of technology partners. ISVS, industry-focused solutions, hardware, and more to help customers quickly access and deploy scalable AI solutions using validated providers that best suit their business needs. The program leverages industry-leading strategic alliances and open-source tools to optimize AI solutions across various architectures, ensuring enterprises get the best performance from their AI solutions.
Okay, so you can see that DeepBrain provides a really engaging UI to give us our answer, and we can use text input. We could also use chat input like you saw, or voice input like you saw in the examples that Joe showed. So here's the overall stack or diagram flow for our chatbot. These are kind of the big pieces, and I'm going to go through most of these here today. So we start with a UI, which is DeepBrain, and a user input on the UI, and then we'll go through a chat API that takes that to our chatbot. I'll go through two large language model frameworks. The first is Nvidia Nemo, and we're going to use a toolkit called Guardrails that's part of that. And we'll also use a toolkit called Langchain that connects to a vector database, which is our knowledge base of internal information. I'll also go through how we're going to use Llama 2, the large language model, on our own local server. And I'll also go through how to give the chatbot identity and behavior that we can define using natural language. So the first thing I'm going to go through is the vector database. This is, you take your internal information, whatever that is, could be an HR knowledge base, could be user manuals, things like that. and how to put that in a format that a large language model can digest. So first, we'll extract all the text from our documents. This really depends on the type of documents that you have, but if you have PDFs, Word docs, web pages, that's pretty easy to do. Next, what you can do is chunk those documents. So you want to do this for two reasons. You're going to split up what could be very large documents into small, digestible, several sentences or several paragraph chunks. And the two reasons you want to do this: first, so that way these chunks are small enough you can fit several into the prompt of a large language model, because the prompt size is limited on large language models, and you want to just make sure that it's able to recognize the important information in each piece of information you put in. The next important factor in chunking is you're going to create a vector representation. So it will be hundreds or thousands of dimensions of numbers in a vector that represents the meaning of that chunk of text. So if your chunk of text is too long and you're trying to vectorize, say, an entire document or an entire book or something like that, it's hard to capture all that meaning in a single vector. But if you just have a couple sentences, then you can get a good representation of those sentences meaning in that vector representation. And then you can go search for, I need sentences about X, Y, or Z, and your vector database will help you find that text. Then we're going to deduplicate the chunks. This is relevant if, say, you have web pages that might include the same headers or footers. You don't want to include that in multiple chunks. As long as you have one, then you'll be able to find it. And then you can create a vector database. And we use a tool called Chroma. It's an open source free tool, and it fits in really well with LLM frameworks like Langchain as a tool that large language models can reference. We can take an input, say like a user question, and create a vector representation in the same way we did with the vector database, and then match that vector representation of the user input to all our thousands of chunks in the vector database and find the most relevant chunks that will help us answer that question. Next, I'm going to go through our chatbot, which includes two LLM frameworks, Nvidia Nemo Guardrails and Langchain. So the first LLM framework is Nemo Guardrails. This is open source from Nvidia, and this works based on a new language that they created called Golang. And so what you're looking at here on the left side of the screen is a Golang configuration file. This is just an example that I put together, but I just want to show how easy it is to create these files and to create guardrails. Essentially, Nemo Guardrails helps us identify if we've identified topics that we wouldn't want our chatbot to go into. So in this case, I've said, I don't want my chatbot to talk about politics. Then we can define just a few, 2 or 3 examples of what those types of prompts look like, and then define how the chatbot is to respond to those. So you can see we define the user ask about politics, and then we give 3 examples like, what do you think about the government? And so we can use these to essentially show these examples to the large language model that we're using and have it classify, okay, is this user input asking about politics or is it something else? And then we just define a bot response. Inform cannot respond. So we can say, as an AI language model, I'm not able to answer that. And then lastly, we just define the flow politics. And this is just like a kind of an if-else statement. In this case, it's just an if statement. We'll say user ask about politics, that's the if. And then if it hits that, if the user is asking about politics, so it's something, if it's one of these items or something like one of these items, then we say bot inform cannot respond, and we've already defined what that response is. So we can avoid risking any generative response here that might be harmful or might have our chatbot give some output that we wouldn't want it to do. Obviously, most of the cases, most of the user inputs won't ask about politics. We're going to want our chatbot to give its natural generative response. And so we define another flow called general. And so we say user ... here means in any other case. And then what we can do here is execute any function that we could write in Python. So here the function would be Langchain.qa, and I'm going to go through next how to use Langchain to query our vector database to answer questions based on our documents. But this will essentially execute that function given the user input, which is the last user message, and then the bot will return that answer instead of a canned answer like we have given above. And this is just a diagram for how that all works. I kind of went through that in the first place. So if a topic matches one that we've defined, such as ask about politics, then we'll give a flow defined response like inform cannot respond. If nothing matches, then we'll go to the next phase or next function, which is Langchain. So we can use Langchain, which is an LLM framework. It has several different chains or agents, and it's essentially a Python library made for using large language models with external databases, such as our vector database, or connecting to different APIs, such as a Google search or something like that. So in this case, we're going to use an object called a QA chain, which will enable us to do question answering based on our knowledge base that we have put into a vector database using Chroma. Essentially, this takes 1, 2, 3, 4, 5 different elements to build. So the first would be, what is the LLM that we're using? And I'll go into how we're going to use Llama 2, but we'll just input that as our large language model. Next is the chain type. And this is essentially, okay, if we have all these different chunks that are relevant, say we have 3 different chunks that are relevant to a user input, 3 different pieces of information from our database that are semantically similar to what the user is asking about, how do we show those to the large language model? If you think about it, there are a couple of ways that we could do that. We could show them all at once, say, here are 3 different documents or chunks of documents that we found that we think are relevant, and just answer the question based on those. Or we could use a refining method where we might show one at a time and say, refine your answer based on this new information. So what I've found is that if we have a large enough context window for our large language model, then using the stuff method, the first one I mentioned, where we're just going to show all the information at once and generate an answer based on those, works fairly well. The prompt format is the exact wording and order of information that we give. So everything that's contained in the prompt will include identity and basic behavior of the chatbot. That can give it a name, a job, some basic rules for engaging with the user. And that's all in natural language, and ideally is a couple sentences. Then we'll use these two in blue each single time that a user asks a question. So we'll input the user query, which is just whatever the user has asked us, and then we'll match that with our context chunks. And so you can see here, this is just 3 lines of Python code to do all of these steps. The first line will receive the documents that are similar to the user query from our Chroma database. That's where our knowledge base is stored. The second line will initialize a QA chain. And so this is going to be constant for each question, but we can give it the large language model, the chain type, and the prompt format. And then each time a user asks a question, we run this third line, which is generating a response based on the user query and the context chunks. And then we can take that generated response and return that to our UI, which is DeepBrain. Okay, like I said, I want to go over how we're using Llama 2 at the edge using Lenovo Hardware. So this is the lowest level. This is just it essentially giving us access to a large language model. One important thing to consider is how much throughput or how many different users can use this large language model at one time. And I just want to bring this to everybody's attention because this is something that's really important for us when we're using large language models. So the most commonly used library for using large language models locally is called Hugging Face. That's represented here by HF. And you can see that if we are running Hugging Face, then we can get about 6.4 requests per minute to that large language model. for Llama 13 billion. That's a 13 billion parameter large language model. If we use a toolkit called VLLM, which is another library that's also open source, then we can increase our throughput by 8 to 10%, or in this case, it actually shows 14 to 24 times higher, 8 to 10 times higher, or up to 20 times higher, depending on the hardware and the model exactly. But so you can really see huge increases in throughput. That's the number of users that are able, or requests that are able to go to that large language model per minute by using VLLM. And that's an open source toolkit from the University of California at Berkeley. So just wanted to bring that to everyone's attention. And that's a big reason or a big important tool for us in using large language models locally that helps it scale well. So this is kind of the basic setup for running a large language model locally. So we have an SE450. This is an edge server from Lenovo on the bottom layer. And we use an A100 GPU in this as well. We can use VMware if we want to run on VMs. We can also do this on bare metal. And if we are using VMware, then we're going to use the GPU on pass-through. So when we're in the OS, in this case, we're using Ubuntu for this app, we can see directly to that GPU and have full access to it. And then we'll run our Lenovo AI chatbot on top of that. And so with this setup, we could probably run about 20 or 30 different instances of this large language model and have several users going at one time. If we really wanted to scale up even further, then we have a Lenovo generative AI reference architecture for running large language models in your data center, where you could have a server that fits up to 8 A100 GPUs. So you can really get a very powerful server that can give you a lot of power for your LLMs. And lastly, I want to go over identity and behavior. So what we've done at Lenovo is we have a chatbot that, will connect to different databases, like our database that was able to answer about Lenovo AI Innovators program. And so for different use cases, different demos, different end users, we want to give it different identities and rules. And so we have a GUI which allows us to define these in natural language to create essentially new chatbots using what we have set up as our large language model chatbot. So we can define an identity, in which case we give it a name, some adjectives, and a job to perform. And then we give it rules to follow for its conversations with users. These are basic rules that it can follow very easily. For more complex rules, we're going to use things like Nvidia Nemo guardrails, where we tell it how to perform, how to respond to certain cases of input. We can also change the length of memory. So in some cases, it might be important for the chatbot to remember several steps back in the conversation. So we might set this number higher, but here the chatbot would remember the past 2 steps in the conversation. So it can continue naturally if someone references something that happened prior. And then lastly, we can set the number of context chunks that it's going to see from our database. Really, that depends on the complexity of questions that you're expecting and the number of documents that you want it to see could impact the performance in answering those questions. Okay, and then building a webhook for DeepBrain is fairly straightforward. So we can use an API tool in Python called FastAPI. And essentially, there are just a few steps that we need to follow. First is enabling CORS, or cross-origin resource sharing. This is what allows the DeepBrain front end to interact with our chatbot server on the back end. Next, we just need a post request method that the AI human tool will send a post request with the user input, and we will just return our chatbot's output as the response to that post request. I like to give a get request method, though this is not required with DeepBrain, but this is just something that if I want to check on our webhook, I can put our webhook as the URL into a browser and just check on, say, the status and see, okay, it still says it's running. And then when I serve the chatbot, if I'm just running this on our server at Lenovo, then we can use a tool like ngrok to post our app to the internet where DeepBrain can see it. So this helps us post it publicly very easily. And so all of these first 4 steps, if you just look up fast API, how to define post request method, for example, that's very easily within their documentation, and it should be pretty simple to implement in Python. ngrok is a tool that doesn't actually require any coding, and you can use their UI if you're interested. So that's the overall chatbot software stack and how we're using large language models on premises to do Q&A over our document database.
All right, thank you, Chris. If you could stop the share.
Yep.
And now we will hit the Q&A. We got plenty of questions. All right, starting at the top, will the slides be shared? So this whole presentation has been recorded, and everyone who registered will receive a link to the recording. If anyone needs access to the slides, they could reach out to me and we'll get the slides to you. There's several questions here about integration with 11 labs. So I would say stay tuned on that. One of our future webinars we're organizing, we are planning to have a webinar with 11 labs. So for the people asking those questions, stay tuned. So can the LLM be deployed on-prem? Absolutely. I think Chris just demonstrated that. And if so, what is the footprint needed? Chris, could you address that?
Yeah, sure. So at the bare minimum, to run something like Llama 2, you probably want an A100 GPU. So we can run Llama 2 13 billion parameters on an A100 GPU with 40 gigabytes of memory there. And we're using an edge server. So we're essentially using the smallest edge server that can fit an A100, which is an SE450 at Lenovo. So essentially, if you can run a GPU, and it's a very GPU heavy workload, right? So that's kind of the smallest footprint that we have for running a local large language model.
Thank you. And what is the average response time? So the average response time depends on the configuration. There's a lot of variables there. It can be several seconds if everything's running in the cloud, and it can be down to 1 second if everything's running on the edge. And also it depends on the complexity of the language models. We also do things that we didn't cover in this conversation, such as smart caching of video. So when the same question gets asked over and over, those answers are cached up and served ready to go all the time. But the main goal is to have a natural conversational experience. I try to explain it to people, like if you have a smart speaker in your house, like Google or Amazon, when you ask a question, there's a little bit of maybe a second or two before the answer comes back at you. That's the goal that we're achieving with the AI humans. Can the avatars speak Dutch? So the avatars can speak any language, actually. So they are language agnostic. And I'm going to skip over. So does Lenovo offer hosted Llama server?
So I think the best answer to that is that we have a TrueScale service, which is essentially servers as a service. So you pay for what you use, and I think that would be a good option for people looking to get into large language models and essentially start as small as you needed to, and then scale that up as you continue to grow your usage.
Okay. And then Chris, this one might be for you too. We have thousands of internal documents, have different views on the same matters. Would your AI point to the differences out from the different sources?
Yes, you could definitely have it look at different sources for a single user input. And depending on your prompt, you could ask it to generate it or synthesize a answer that connects all of those, or identifies differences between your sources as well. That is definitely dependent on the prompt and how you ask it to output its response, but you could definitely show it several different documents at one time.
Got it. And could you support multilingual in one conversation? So that could be supported. It hasn't been deployed to date, but absolutely the language detection option is there. I have several people asking about pricing on the SE450. Chris, I'll pass those contacts along to you. We don't need to get into pricing on this live webinar.
Sounds good.
And coming on down here, more questions. Do you have some fine-tuned language models dedicated to certain areas, such as financial or healthcare industry? I think we could both answer that, Chris. Why don't you take it first, and then I'll share the DeepBrain answer.
Sure. From a Lenovo standpoint, we don't have, so we do have some projects with especially financial partners, and we have built large language model tools using DeepBrain with them. I think that that really depends on a case-by-case basis for, if fine-tuning is needed and what kind of fine-tuning we could do, but we have done that before. Go ahead,
Yeah,
Joe.
I would share the same answer. We have worked with Lenovo on a financial tuned large language model, and we're really not limited in tuning to a specific domain at all. So whatever custom domain that wants to be deployed, we can tune the large language models to that. But absolutely, we do have a financial large language model. Okay, is the AI human video rendered after all the text is generated by the LLM, or does it start rendering in chunks? It starts rendering in chunks. Okay, this is about building the vector database. Can that be done on premise, or is that done in the cloud?
Yes, that can definitely be done on premise. It's a much smaller embeddings model that we use. It's if the Llama 13 billion parameter model is obviously 13 billion parameters. For an embeddings model, you're looking at hundreds of millions of parameters, so it's much smaller, and it doesn't require a heavy GPU or anything like that. So that's definitely something that you could do on-prem.
Got it. And then we have a customer use case outlined here. It's pretty detailed. I just want to let that person know we will reach out after this event and get back to you on that one. And then questions still coming in. Thank you for all the questions. Keep them coming. Can the avatar be integrated with custom voice in Azure? Yes. DeepBrain is a partner with Microsoft, and we're fully integrated into Azure. So this question, does Lenovo offer testing algorithms on quality such as bias, hallucination, and harm?
That's a really good question. We have done testing. We're still kind of building out what the holistic look of that looks like, and our team is really dedicated to benchmarking and things like that. This is definitely something that we would look at on a case-by-case basis for what's really important to the end user. But we have a team that can work with you on that if you're interested.
Okay, excellent. And I think that's it for the end of the questions. Thank you to everyone for attending this webinar. Thank you for Chris and all the cool stuff you're doing at Lenovo. This webinar has been recorded. YouTube link will be available in about a week's time. And if you have any questions, you'll receive a follow-up email thanking you for attending, and you can get to me. And if you want to reach Chris, I can introduce you to Chris as well. So any closing words, Chris?
Thanks, Joe. Thanks for having me. Hope this was helpful. And please feel free to reach out to me if you want to follow up and have any other questions.
Yes, thank you. And to all you startups out there, Lenovo and the AI Innovators program, I can't recommend it highly enough. And with that, I'll say goodbye to everyone.